Today we're going to talk about vectors in a plane, and the easiest example I can talk about vectors, it's a velocity, for example. So velocity has a magnitude, which is essentially, if we're talking about a vector, which is just an arrow, okay, would be how long this arrow is, and it also has a direction, all right? So you're going to see this represented in different ways, but basically you'll see something like this. This is basically what I'm normally used to is, let me wait for my computer to wake up here. Essentially, you'll see something like this with an arrow on top, or sometimes is denoted as this. Now, the magnitude of the vector is denoted as this. And there's also something called a scalar and scalar quantities, right? A perfect example of a scalar is like your speedometer, right? It tells you the speed at which you're going, but it does not tell you direction. It's just, that's what a scalar is, right? A scalar is just a number that does not indicate direction in any way. So there's some terminology here that you should probably read on your own. It's not terribly hard, but it is. There are some good things on here about it. Okay, so now we're going to talk about scalar products and vectors. So essentially, if you have a scalar, which is just a number, remember, okay, and I multiply that times a vector. So for example, if this is vector v, all right, and I have 2 times v, so that's just going to increase the length of the vector, by a factor of 2. It's still going to face in the same direction, all right, but it's going to have twice the magnitude, if you will. Now, if you have a negative 2v, then it's going to be the same length as the previous, or the same magnitude as the previous arrow that I just drew, or vector, but it's going to be pointing in the opposite direction, right? 3 halves v, well, think about it, right? 3 halves will be 1.5, and it is positive, so I would start here. It would have the same direction, right, but it's slightly different magnitude. And finally, if you have a negative 1/2, well, again, it would have sort of the same angle, but it would be coming in the opposite direction. And I drew that on the wrong length. Should be about half that big. Okay. So that's that. So let's talk about, again, what I just talked about. How do you find the magnitude of a vector? And if you think about it, and I'm actually going to talk about how do you find that by doing the first example. All right. So essentially what you have here is a vector that's given to me, and it's right here, right? So I'm going to write 3, 7. I'm going to put a dot on 3, 7. Okay, and it ends. So that's the tail, if you will, and the head is going to be at 6, 5, which is right here. So essentially what I have is this vector, okay? Now, to find the magnitude of the vector, or how long that vector is, the length, all right, what we could do is we can do a Pythagorean theorem, right? If I find the x coordinates right here, this is what we call like x2 minus x1. And then if I look at the y coordinates, right, which we call y2 minus y1, then essentially what we have is the length of this vector, right? If we square this, and we square this side right here, that's going to give us the magnitude of the vector, all right? So essentially what we have is this formula. Okay, so to write the component form of a vector, it's actually very, very simple. What we're going to have to do here is just basically find the change in x and find the change in y, and that's going to be it, all right? So I'm going to write this as, let me change that to black again. V is equal to 6, which is the x coordinate, minus 3. No particular order. If you do it the other way, it should still work. Oh, excuse me. No, you don't. You want to do it. This is x2 and this is y2, right? Because that's the head and this is the tail. So you definitely want to keep it in that order. So 6 minus 3, and then we have 5 minus 7. All right, so to write this in component form, all you have to subtract those, and you should have the rest of it, right? So we have 3, negative 2. Now, to find the magnitude is basically what I just said, right? So we're going to find the differences. All right, this is the symbol for the magnitude of the vector. So basically, we can take the difference in x, which is right here, and the difference in y, and then which are these numbers really, right? And then we're just going to square them, and then add them, take the square root. So it's essentially a Pythagorean theorem. So this is going to be the square root of 13. All right, so now the next one says sketch the vector AV and the translated vector V. Now, to sketch this vector that I have here, okay, I can write it like this. I'm going to do it in a different color. So we have, let's see, 3. So you start from the origin. Excuse me, I have a hair on my screen. I know you can't see that, but it bothers me. All right, so we're going to start from the origin, and we're going to go to so again, we start here, and then we're going to go to the right 3 and down 2. Okay, so this is the tail, and this is the head right here. So that is the translated vector, okay? And notice again that you're facing the same direction, and you have the same magnitude, or the length of that vector is the same. All right, to add two vectors together, it's actually very simple. Graphically, what's going on is that we can, let's see, we can rewrite this vector A right here. So let's see, over 3 up 4. Okay, this was called vector A. And then to add vector B, well, the only thing you have to make sure that you're doing, whether you're adding or subtracting, all right, let's say this is 4 here. When you're adding two vectors together, you have to add them head to tail. All right, so again, you have to add those vectors head to tail. So now, as you can see, the resultant vector, this right here would be A plus B. So this would be the result of that vector. Okay? So now, on the next one, if we're subtracting two vectors, and same thing, A is going to be the same exact as what we had earlier. So it's going to be that long for A. But B, because it's negative B, it's actually going to make that vector B basically be the opposite. It's going to point in the complete opposite direction. All right. So because I'm pointing straight to the right, in this case, I'm going to point straight to the left. And I probably should have put this somewhere else just because I'm not going to have enough room. So let me redraw this real fast. So 4, okay. So this is A. And B is going to go the opposite direction. So this is negative B right there. So then the resultant vector would be right here. Okay? And then finally, if you have 2A plus B, well, what that means is that we're going to lengthen the first vector. So I'm going to start all the way down here. All right, so remember the first vector was over 3 up 4. So twice as much as that, I would have this one, and then I would have that again. All right, so notice that length right there would be 2A. And then if I want to add B to it, then I would start here. Remember, always head to tail. And that would be vector B. And finally, the resultant vector would be this. Okay. Pretty simple. I hope you agree. Now, we have certain vector operations that for me, and I think for most of you, is going to be pretty common sense on this. All right. So when we have something like having -3 of vector u, remember vector u has this coordinates right here. All right, so all we would do is basically multiply that scalar, right? And I want you to get used to hearing that word. That scalar, and this is the scalar, by the way, times that vector. So this will give us 9 comma, negative 24. Okay, and that's it for that one. On B, same thing. If I have 2u, I'm going to multiply vector u, which in this case is negative 3, comma 8. And then vector v is going to be multiplied times 3. This is 5, comma 2. And then I will then distribute this scalar. And I'm going to write this as plus negative 15 minus 6. And then to add two vectors, remember all you do is you're going to add the first term together, which I guess we can call the x term. So this is going to be negative 21, comma, and then 16, and negative 6 will be 10. So that's the resultant vector from that, okay? Now, notice that symbol right there, the one that looks like an absolute value, but double that, right? It looks like a double absolute value. That stands for the magnitude, right? So the first thing I have to do is I need to find what? 2u, which is 2 times negative 3, and 8 like this, minus 3, and this is 5, 2. So I basically need to find out what this is first, right? So I need to end up with just a pair of numbers. All right, so we're going to distribute that scalar. And if you don't mind, I'm going to go ahead and skip a steps here. So 2 times negative 3 is 6. Negative 3 times 5 is 15. So I have negative 6 plus negative 15. That's going to give me negative 21. Well, now I have 2 times 8, which is going to be 16. And then negative 3 times 2, which is going to be negative 6. So, and I guess if I would have been smart enough, I would have just looked at the previous problem because that already has that vector for me. All right, so now we're going to find the magnitude of that vector, right? So to do that, we have to do basically a Pythagorean theorem. We're going to find the change in x and the change in y. In this case, I already have that. So this is going to be negative 21 squared plus 10 squared. And that's going to be equal to the square root of 541. If there's a chance to simplify, do it. Otherwise, just leave it alone. All right, so on letter D, right? Example D on this one. Same thing. First, we're going to subtract two vectors. Remember the u. Let's see what u was. U was negative 3, comma 8 minus vector v, which is 5, comma 2. And remember, when you subtract them, well, you're just going to pair them up. This one with this one, so that's going to be negative 8. And then 8 minus 2 is going to be 6. And to find the magnitude, remember that means stands for the magnitude, then I have to do the Pythagorean theorem formula again, where the change in x would be this, plus the change in y, which is this number. And then in this case, I would get 100, and the square root of 100 is 10. All right? All right, and that definitely needs to be positive because we're talking about the magnitude or how long a vector is, regardless of direction. All right, so again, anytime I ask you for magnitude of a vector, you should not have a negative number. All right, I'm just asking you for how long something or a vector is, excuse me. So now we have another thing called a unit vector. All right, so if we have a unit vector, it's basically a vector that points in the same direction with a magnitude of 1. All right, so it's a vector that points in the same direction as the original vector, okay, and it has a magnitude of 1. All right, so that's the important part about that. So to find the unit vector, we're going to use this formula right here, or the other one is basically the same. So first, what I need to do is, let's see, let's call this u. This would be 5, 15, so that's not going to change, okay? All over, the magnitude of the vector would be the square root of negative 5 squared plus 15 squared, okay? So this would be Let's see. -5, 15. That's going to stay the same. On the bottom, I would have this. If you simplify it, I think it's 250. So the square root of 250 is 5 square roots of 10. Okay. And then to write this as a unit vector, well, we're just going to divide each one of these by 5 over square roots of 10. And let's rationalize the denominator here. So that, of course, is going to leave me with -1 over the square root of 10. This will leave me with 3 square roots of 10. So again, we're going to rationalize the denominator. So my final answer would be negative square roots of 10 over 10. And this would be 3 square roots of 10 over 10. Now, if you are in a test and you want to make sure that what you did was correct, notice that it says verify the length is 1, meaning if I find the magnitude of this unit vector, I should get 1. All right, so again, if I take this and square it, and I add it to this, and then I square that also, that should get 1. And I do in this case, okay? So that's a good way to check that in case you have a homework problem or a test problem that you want to make sure you got right. All right, so now we're going to talk about linear combinations. So the standard unit vector I stands for this, right? So I is 1, 0, and j is 0, 1. So, and that can also be used to represent any vector. So it's really no different than writing it like this, right? It's the same idea. Okay, it's just written a different way. Okay, so writing like that or like this is basically the same as just a different way of doing things. So let's go ahead and talk about this, okay? It says let u be the vector with initial point 3, -5, and terminal point -2, 4, and let v be equal to 2i minus 3j. Write each of the following as a linear combination of I and j. Okay, so u, all right, the first thing I have to do is sort of like I did at the beginning, right? We're going to call this, remember this is like my x of 2, and this is my y of 2, and this is my x of 1, y of 1, all right? So same idea. So I have -2 minus 3. I'm finding the difference between the two, and I have y2 minus y1, which is going to be 4 minus a -5, which is going to make that a +5. All right, so we normally write it like this, right? But another way to write that would be exactly the same as -5i. And some people write it like that, okay, to indicate that this is not necessarily a variable, but it's a vector. Basically, I and j are unit vectors, okay? So they could write it like that. They can write it just as I and j. I don't really care which way you write it, but I just want you to be aware. All right, so on B, we're going to do it almost exactly the same way as we've done before, right? So we have 2 times the vector -5, 9. This is -3, 2, -3. So this is -10, 18. So again, I'm just distributing that scalar, right? And I'm going to write that as plus -6 plus 9. Excuse me, 9, not plus 9. And then we're going to combine those x coordinate terms, if you will. So again, maybe I shouldn't say x coordinates. This is not really an x and y coordinate. This is not a point on a graph. But it's something similar. Essentially, that would be the tip. If you want to look at that, -16, 27 would be the tip of your vector. This starts on the origin. Okay, so that's that for that. The unit vector w, well, same thing as what we've done before. What's w? Oh, w is the previous problem. Okay, so on the previous problem, we want to remember to find the unit vector, we have to write this vector right here. And it's a lot easier if you do it like this instead of with the i's and the j's. Then we're going to divide that by the magnitude of that vector, which is the square root of -16 squared plus 27 squared. So in this one, that's going to leave me with negative 16 over the square root of 985, excuse me. I'm going to write an I here, and I'm not going to write an I with a hat on it, if you will, just because the notes do not, but if you did, that's not wrong either. So that's what it would be on this one. Okay. So let's talk about direction of an angle and vector. So on this one, some of this is very trig oriented. All right. So notice that what's gonna happen here is the following. All right. So let me switch to my notes so I don't make a mistake here. Okay, you cannot figure this out honestly without even having to know all of this stuff that's here because you should already know. All right. So let's say that I have a magnitude, or excuse me, we have an angle which is 30. They tell me the length of that vector is 4. So this is very much like a physics problem in essence, okay? Now, what we're going to try to find is basically the x and the y coordinate, okay? So to do that, you can either look at the formula that I have above, all right, which is right here. Well, this would be like the x coordinate, if you will, and this would be like the y coordinate, all right? And you also have, if you didn't have the angle, you can find it like that. All right, so what I could do from here, if I wanted to, right, is I know the cosine, for example, the cosine of, well, I'm going to write theta even though I know it's 30 degrees, would be equal, and let's call this, let's call this A, and let's call this B over here. All right, so the cosine would be A over 4. So essentially what we're saying, very similar to what we did before, is that A, which is that side, is equal to 4 cosine of theta, or in this case, cosine of 30. Right, and side B would be the sine. Let me write 30 here so to avoid confusion. That would be B over 4. So B would be equal to 4 sine of 30 degrees. So as you can see, I mean, yeah, you have those formulas, but you really shouldn't need them, okay? So again, remember I told you, if I don't have to memorize something, I won't. So on this one, I'm not going to memorize it because it makes sense, all right? So what they want us to do is to write the vector v as a linear combination, all right, of the unit vectors I and j. So therefore, all I have to do to figure out this vector, right, essentially what I'm doing is very much like a physics problem. I am breaking that vector into its components. I want to know the x component and I want to know the y component, all right? So what I could write it like this. So v is equal to cosine, 4 cosine of 30 degrees. I will put a hat on it, change my mind. Plus 4 sine of 30 degrees j. And essentially what I do there and just figure out what those numbers are. This would be the square root of 3 over 2. And this is 1/2. So v is equal to 2 square roots of 3i plus 2j. Okay, so that's the first thing that it's asking me for. And then after that, it says if the magnitude of the vector is 4 and they, okay, well, do I need to know anything else? I guess not. So that's it. For a second, I thought they were asking for the magnitude of the vector, but I realized that I already have that. So essentially, if you're talking about maybe in a projectile motion or anything like that, this would be the I term would be like the velocity. If we're talking about physics, right? I know this is not physics. That would be like the velocity in the x direction, and the 2j would be the velocity in the y direction. So that's why this is going up and to the right. Okay. Now we're gonna go to number 8, where we finally have a physics problem. Okay. Now, your notes that I originally had did this in a very strange way, but luckily for you, you have me. All right, so now I'm finally going to get to teach you physics. I know that's what you always dreamed of. Okay, so when you have something that looks complicated like this, okay, first of all, it says a weight of 500 pounds. So we're going to consider that a force, okay? So we're going to consider that pounds as being a force. So now, what we're going to have to do to figure this out, first of all, notice that we're looking for the magnitude of the force of the two cables. So there's some kind of force that it's normally called tension, okay, in physics. All right, so we have two tensions, one on the left, one on the right. And we're trying to figure out the tension on cable 1 and 2. All right, so to do that, and also, is that it? Okay, no, that's it. So what we do always, all right, any physics problem, especially one that's about a force body diagram, is we draw our force body diagram. That was kind of repetitive. Okay, so we can say, let's say that this is right on 0. So this 500 pounds is just pulling straight down, right? So we're going to call this force 3. And then we have this other 2. We're going to call this force 2. And again, those forces normally we call it in physics tension, which is a type of force. So we have force 1 and force 2, all right? Pull in that direction. Now to figure out the, what am I calling it? The angles, all right, which is what we need to find, is first, what we could do, if we had something like this, and this right here is 65 degrees, right? That means that this angle is also 65. And by the same logic, this angle is going to be 25. All right, so I'm going to delete this last little part here because I don't, oh, come on, delete. But essentially, that's how I know what those are. All right, so now what I have to do is I'm going to have to add up all the forces in the x direction. And this is we're going to have to use. And by the way, is this moving left or right? As far as we know, it's not. It's staying right in the middle, so it is not moving left or right. So when you add all the forces in the x direction, you should get a 0. All right, now we know the force 2 is pulling in the negative x direction. So I'm going to call this negative. So when I add this force, right, the x component of force 2 is going in the negative direction. Okay, now we're going to add the other x force, which in this case, the other force is in the x direction is force 1. All right, now notice that the x component of force 1 is pointing in the positive x direction. So therefore, this is going to be positive f1 of cosine of 65 degrees. That's equal to 0. Okay. Now we're going to add all the forces in the y direction. Now, sometimes you can solve at that point, but there's really too many variables here. I don't have a way to solve for any one of them. So we're going to add all the forces in the y direction, okay? Now notice, by the way, that force 3 is just pulling straight down. So I don't have a force, I don't have an x component to force 3. Okay, so the forces in the y direction are going to add up to 0. How do I know this? Because it's not moving up or down, okay? If it was moving down, I would have a negative force, okay? And if I would have a positive, that means it's going up. So in this case, because this weight is not moving, we can say that the sum of all the forces in the y direction is 0. So the forces in the y direction, let's start off with with force number 2. The y component, all right, of force 2 is pointing in the positive y direction. So this is going to be positive. And the y component of force 1 is also pointing in the positive y direction. And then finally, you have force 3 that's pulling straight down with a force of 500. And by the way, I'm not a big fan. I wish they would have just used math so we can use gravity, but they didn't, so I guess I won't. So this right here is what I have, okay? That's accurate as far as I know. All right. So now, what I have to do is basically find a way, all right, to use these two equations to solve for either force 1 or force 2. Now, the next step I'm going to do here, because I can kind of see something already happening, is I'm going to go ahead and add 500 to the other side on the sum of the y forces. Now, what I have here is that you can set up a system of equations, which if you want to get really fancy, and remember, if I have a calculator, which at this point you should have a calculator, is that I would totally use a system of equations, because we can call this equation 1, for example. We can call this equation 2. And if you know how to do this in 84, you have to use the matrix key, if you will. All right, so you press like second matrix, and then you're able to just plug in those numbers, and at the end it's going to give you force 1 and force 2. It would be truly great if you could do that. But let's say that I'm not quite as advanced. And in that case, you still have to set up a system of equations, but you're going to have to solve that by hand. Now, in Mathland, right, we can use elimination or substitution. Okay, but I tend not to do elimination on this because it's a little bit more difficult, all right, than what it normally is, because the sine of 25 and the cosine of 25 are now going to be nice whole numbers for me. So what I'm going to do instead is I'm going to use function 1, all right, so I'm going to just name it here. I'm just using function 1 here, and I'm just going to solve, basically I'm just going to set one force equal to the other, right? So I'm going to add force 2 cosine of 25 to the right side. So now I have force 1 of cosine of 65 is equal to force 2 of cosine of 25. Okay, at that point, all I'm going to do here is I'm going to solve for F1. So force 1, right, that's going to be equal to the cosine, force 2 times the cosine, force 2 cosine of 25 over cosine of 65. And if you wanted to, you can go ahead and just put that put cosine of 25 over cosine of 65 and get a number for that if you like. All right, and then now what I'm going to do is I'm going to plug F1, which is this one, into equation 2. All right, so I have, let's see, F2 sine of 25 plus F2. Now, at this point, right, I'm talking about equation 2. I would normally write sine of 60, I would write F1 sine of 65. But I'm going to replace that F1. I'm going to replace that F1 I'm going to replace that F1 with F2. I'm going to write it like this. It's the same thing. Cosine of 25 over cosine of 65. All of that times the sine of 65 degrees, right? So just to make sure that I haven't lost you yet, what I replaced was, I replaced this right here. I replaced that with all of this right here. Okay. So now, let's see, all of that was equal to 500. And essentially notice that now I have one single, I can factor out an F2. All this other junk can become just a number. But I'm kind of weird, and I don't like to actually get a number for that because I like to be as accurate as possible. So essentially what I'm going to do here is I want to get a number for this on my calculator. And then I want to divide 500 by that number. All right, so whatever this number ends up being right here, I want to divide both sides by that number. So 500 divided by that weird number is going to be 211.309 pounds. And then on force 1, all I have to do is just plug in force 2 into either equation 1 or equation 2. It doesn't really matter which one you use, and then solve for that. Okay, so let's see. F1, well, since I already have F1 right there, right below here, I already have that, so I'm going to just use that equation. Looks like it's set up, prime, and ready to go here. So we have 211.309 times cosine of 25 over cosine of 65. So function f1 is equal to 453.165. Well, I'm glad I taught you a little bit of physics. It kind of warms my heart, my cold, cold heart. All right, so those are the two forces right there. All right, compared to polar coordinates, I think this is a lot easier to understand. So if you have any questions, let me know.